Hello everyone, my name is Viet Dong, and today's my presentation is about a hybrid system on the left side and solar system on the right side. And our goal at the end of project, we can combine them together to connect into the house. Uh, Number one is to reduce cost. Number two is to stay off the grid if we wanted to. Number three, if we can use a backup system if we have small commercial house, or we can power up this system everywhere in the world. So on the left side, as you can see, the hybrid system. So hybrid system, we have hydrogen power going to the batteries right there, and then we have smoothing capacitor, we have battery booster, we have gate dry circuit, and we have IBGT control module. And then down here we have motor and generator. And so when we slow down the power from motor and generator, we will do the converter, DC to DC converter, to diode rectifier. It's make AC wave into DC, as you can see down here. And then it's moved out through the capacitor and go back to the battery and charge it. That the whole system function is. And on the right side, it's the solar power system. So solar power system, we have solar, and we have charge controller, and then from charge controller it go into the batteries. From batteries go into the AC inverter, and then from the inverter it will power up the light bulb or DC motor today. It's our output. So the two output is here, so I set it up with the light bulb and DC mode, as you can see here. Okay, and let's look at the hybrid component closely. So the hybrid component, we have the batteries right here. So the battery, we have these two terminal, this terminal and this terminal going in now, and we have the management battery management system on the top of it, but I took it off. So the management system is to monitor the voltage, the current, the temperature of the battery before coming out, and it talks to the control module right here to see if, how much power is needed to provide for the motor, and when it should disconnect if it feel unsafe. So that's the main point of management system on the top, which I remove it already. And so from the battery, it will go into the drive controller. So the drive controller, we have three components. We have capacitor, we have voltage booster, and we have IBGT driver. So the power from our batteries that go in here to the capacitor, and then it go into the voltage booster. So this voltage booster function is to boost up 140 volt for volt DC up to 600 volt before it go into the IBGT inverter to give the motor a little bit more power. So this IBGT, and you can see here, let me go close. IBGT, we have three set of transistor. We have this one set, this second set, and third set, and we have a dry circuit. So this dry circuit will turn on and turn off that IBGT so quick to make it DC, to make DC become AC, as you can see in here. So that our DC signal is like that, it's just a pole, and when it turn on and turn off so quickly, it make it look like an AC current, AC signal, and the motor doesn't recognize it. It say, wow, I see AC motor is running. And you can see here we have set 1 for phase 1, set 2 for phase 2, and set 3 for phase 3. And when the motor slow down, it will go back to this IBGT again, and it convert that power to charge our battery system. And how we do it, so when the AC from the motor, when we brake or we slow down, it is at AC, and then it go through the transformer right here. go through the transformer, and from this transformer will step down to the voltage of that battery, which is 104 volt, and go into the rectifier, diode rectifier here. So this diode rectifier will make AC into DC, and then smooth it out, and then go into the battery bank to charge the battery bank, as you can see here. So it make AC signal into DC. You know, by take the top part and bring it down here, the bottom part bring it down here, top part bring it down here, and bottom part bring it out here. So it make it look like a DC signal, and then it charge the batteries. And finally, we have the last component is our converter. They call it converter to converter. So it, as you can see, the two wire. So it take voltage directly from our battery, 144 volt, and then it bring in here. So there's two set of this one. So number one, we have a DC to DC converter right here. So high voltage DC, you go in here, and then go through the transformer, and the transformer will step down the voltage and bring it over here to 14 volt DC to charge up the battery in our car. Okay. And it's also have the inverter set down here. So the inverter set down here, so it take DC, as you can see here, on down the transformer, and then bring it down here. So they have the inverter right here. So phase 1, phase 2, and phase 3 to power up the HVAC and heater in the car. Okay. So summary. So what the motor does. So when we accelerate, so this motor controller will talk to the battery. Hey, I need some power to run, right? And when it slow down, the power going back here, and it will send back to the battery and charge them through this inverter. And this converter, the main point is to convert DC, high voltage DC into low voltage DC to charge up the battery. And it's also have a small junction of inverter to use heater and air conditioning in our car. And let's move on to our solar system. So our solar system, we have right here. It's outside. So we have a solar panel outside with its 14 volt, 13 amp. And from that solar, you can see there's two wires right here. They go into the charge controller. So the voltage at the solar right now is 14.2, we jump down, 13.1 volt. Well, it is flexible. And from the power here, then go into the battery to charge the battery. And the job of this charge controller is make sure the battery is full, the battery is fine, and when it's full, will shut up by itself. And as you can see from the batteries, is a 12 volt battery which I borrowed from my friends. So from the batteries go into the inverter. Okay. And this inverter job is to take DC. You take DC here and convert it into AC. And you can see this wire right here, DC. I don't have the house panel at home, so I just hook it up in here. As you can see that right now we have let's see, we have 100 volt AC voltage coming out, going in here. And right now I set it up at amp, so there's no load. So let's turn on our load and test it out, our system. So with the light bulb, so we're gonna turn it on and see how many amp is used. So as you can see the amps right now, we use 10 amps for that bulb, right? And the second output that I introduced earlier is our motor, DC motor. And DC motor setup, we have the motor 90 volt. We have a 90 volt DC motor. We have a speed controller. And we have motor drive and driver control. And now let's test it. So we're going to turn it on. So when we turn it on, you can see the live flashing and speed controller right there. Okay. And in the speed controller on the right side, we have the start button right here. And we have a stop button on this side. And then we have a speed control right here. So let's start it. And you can see the motor is running. There you go. It's running. And then we can increase, we can make the motor run faster by increase the speed. Woo! Slow down. Vibrate. Okay, you want to slow down. There you go. Thank you very much. That's the end of my project.